In this video we're going to work out the volume underneath this surface in this given region. But the thing is, we have no idea what that given region looks like, so we need to investigate. So looking at the inner integral here, you're working with dy first, so that would mean y equals something, y equals something. You're moving from y equals 0, which is this line here, and then you stop at y equals 1 minus x, which is this diagonal line here. So you're actually doing this. You're scanning from y equals 0 to the line, y equals 0 to the line. And looking at the outer integral, you're scanning from x equals 0 to x equals 1. So x equals 0 is here, x equals 1 is here. So you're actually doing this. You're scanning from x equals 0 to x equals 1. So this is our region. So in order to evaluate this double integral, if we make this to be u, and if we make this to be v, then life becomes a lot easier. So this thing here will then become this, and then this thing here will then become v squared. So here you're working in terms of x and y. So you're working in terms of x and y. When you make this substitution, you're actually working in terms of u and v. So when you make this transformation, this region here would have morphed into something else. I don't know. Let's just say it's this region here. So the good thing is that by making this substitution, the integrand becomes easier to work with. But then when you make this substitution, you will need to make some sort of adjustment, and this adjustment is what's called the Jacobian, which I will show you how to compute later on. And you also need to make your adjustment. You need to make the adjustment in the region. So this region here would have changed if you make this transformation. So we need to make the adjustment in our region. That's our next step. We will leave this to later on. So let's concentrate on our region. But in order to work out our new region, let's make x and y the subject. It would make our life easier. So looking at this, eliminate the y. So add 2x to both sides. So that would be v plus v plus 2x equals y. So put this into the y. That will help us eliminate the y. So this thing here will then become this. Will then become this. So now rearrange it to make x a subject. So now we've got everything in terms of x. So now let's do the same for y. So going back to our transformation, let's eliminate the what are we eliminating? Let's eliminate the x. So looking at this, eliminate the x. So times everything by 2. So 2u equals 2x plus 2y. So we can add these two together, and that will eliminate the x. So adding these two together, that will then give us this. That will then give us this. And then rearrange it to make y the subject. So now we've got everything in terms of x, everything in terms of y. So let's start again. By making, we are trying to work out this double integral. By making this substitution, the integrand becomes a lot easier to work with. It will become a lot easier to work with. But then we need to investigate what happens to our region. So let's look at this line here. What happens to this diagonal line here? So making this substitution led us to this. So now we can ignore this and use this. It would be a lot easier to work out our region. So let's investigate what happens to this diagonal line. So let's look at the diagonal line. So looking at the diagonal line, put this into the y, and then put this into the x. So this whole thing here will give us this. Remember, we are trying to work out what happens to this diagonal line once you make this substitution. So rearrange it. So it's blah blah blah. Rearrange this. Blah blah blah. So u equals 1. So what that means is this diagonal line becomes u equals 1, which is this vertical line, u equals 1. So this diagonal line will get morphed into this vertical line under this substitution. Okay, so now now we've got this vertical line. This diagonal line becomes this vertical line, and then now let's investigate what happens to this line here. So this line here is y equals 0. So let's look at the line y equals 0. So put this into the y, so that this thing here will then become this. So rearrange it to make v the subject. So now we've got this line. So under the uv world, this thing here would look like this. V equals minus 2 u would look like this. It's a diagonal line, gradient of negative 2. So this line here would then become this thing here. This diagonal line here would then become this vertical line here. Okay, so now let's investigate this particular point. This particular point has the coordinates 1, 0. So now, hang on. Now look at that. Let's look at that particular point, 1, 0. So this is our x, this is our y. So let's put this into here. This thing here, x is 1. So we've got this at the moment. So now we've got this. See, this is our x here. This is our x equals 1. And this is our y equals 0. So we are trying to investigate what happens to this point here. We are trying to investigate what happens to this point, 1, 0. So that would take us to here. Hang on. That would then take us to here. So this is our point, 1, 0. That would then take us to here. Rearrange this so u equals 1 and v equals negative 2. So what that means is that particular point, this particular point here, becomes 1, negative 2. So what that means is, hang on, what that means is this particular point here gets morphed to this point here. So let me just summarize. This diagonal line here is this vertical line. This line here is this diagonal line. This particular point here is actually this particular point here. So let's investigate further. So our region, we can use the same technique now. Let's investigate what happens when x equals 0. When x equals 0, hang on, I'm a bit lost, bear with me. So now let's look what happens when x equals 0. So let's look what happens to this line here. Well, this line here, let's put this into here. So this thing here will then become this. Under this transformation, this line here will then become u equals v, which is a diagonal line like this. So because this is a diagonal line of gradient 1, we know this is going to be 1, 1, this point here. But the point is that this vertical line here is this bit here. This line here is this diagonal line here, and then this diagonal line here is this vertical line here. So under the transformation, this region here becomes this. So from this we can make our adjustment. So hang on. So let's start again here. So here, up here, this is our region. Under this transformation, this region becomes this. So now we are working in terms of v and u. So under this transformation, the integrand becomes a lot easier to work with. It becomes this. So now we can make our adjustment. So here, working in the movement, so working in the direction of V. So we're moving along like this. We start here, we're moving along in the direction of V. So we're moving from this diagonal line, which would be minus 2u, and then we stop at this diagonal line here, which is V equals u. And then now looking in terms of u, so we're scanning from u equals 0, and then we stop when we get to u equals 1. We stop when we get to u equals 1. So we start at u equals 0, we stop at u equals 1. And then later on we need to work out this Jacobian, which I will do in the next video. So we are currently here at the moment. Okay.